Assalamualaikum my students, welcome to our last topic, that is properties of definite integral. We have already discussed them and now we have the application of this property, how we can apply them in our integrals. So the first integral that I am taking here is, if we have integral I equals to 0 to pi divided by 2, if this integral is, this function is continuous from and this interval 0 to pi divided by 2, and I have to find the area, or I have to find the definite integral of this very function between the 0 and pi divided by 2. Now we can find out this by several methods, but here we have to apply the properties of definite integral. So we will write here, we have I equals to 0 to pi divided by 2, and then under root cos x divided by under root sin x plus under root of cos x. So but we know that by the property of, or the definite integral, the second property, that is, if we have an integral a to b, f of 0 to a f of x dx, it is equal to, by the second property, 0 to a f of, we can substitute this x as a minus x dx. This is our property number second. So we can apply here. Here we have again 0 to a, this function, and we know that a, we have here pi divided by 2. We know that we can apply this formula when the integral is like this. So here it will be I equals to 0 to a, that is pi divided by 2, under root of, what is cos, what is f of a minus x, that is, whenever we have x, we have to substitute there a minus x, but a is here pi divided by 2, so it will come out as cos of pi divided by 2 minus x. Then we have divide this under root of sin x, that is pi divided by 2 minus x now, and then plus under root of cos of pi divided by 2 minus x dx. This is our integral number first. So this, I have this question now, and now here we know that beta this sin this pi divided by 2 minus x is cos x, and cos of pi divided by 2 minus x, that is sin x. These are the very important formulas. We have already got them in our question, in our previous lectures. In 10th we have also what's it about these formulas? We know there that the sin 90 minus x, here pi divided by 2 denotes 90, because pi denotes the value of 1. It is here 1 pi divided by 2, that is 90. Now it will be here I equals to here now 0 to pi divided by 2, where it is under root of cos 90 minus x, that will be sin of x, because cos 90 minus x, that is sin of x, divided by, here it is now sin 90 minus x, that is cos of x, plus here it is again, it was sin, so it will come here, it is cos, so it will be now under root of sin x. This is my second. We will add now this first and second. Add first and second, we get this is I, and this will get plus with I, so it will be here now 2i, I plus I is equal to I, and 0 to pi divided by 2 under root of cos x divided by, this is my under root sin x, plus under root of cos x, plus I have now added this function by this integral, that is 0 to pi divided by 2, I have already written it, so I will write here, plus under root sin x divided by this one, that's under root cos x, plus under root of sin x, and then we have dx. Now we are getting our integral equals to Over here we are getting 2i equals to 0 to pi divided by 2. Here you check the denominators of both the functions are same, so we will write the denominator as single LCM, that is under sin x plus under cos x, and the numerator will be now here it is under cos x plus this is under sin x, and we have then dx. So we are getting 2i equals to under sin x plus cos x. Numerator and denominator both are same, so they will get cancelled out, and here it will be 0 to pi divided by 2 dx, that is dx, and the integral of dx, that is x, from 0 to pi divided by 2. So here by the fundamental theorem it will be now pi divided by 2 minus x के बदले 0, that is 0. So it is now 2i equals to pi divided by 2. But here this 2i, 2 is multiplied with I, so it will get divided, so it will come out here as pi divided by 2, and this 2, that is 4. I am getting the value of my integral. I am getting value of I equals to pi divided by 4. This is my solution. I is this, and the definite integral is pi divided by 4. So I run this on this curve, and the bonus x is equal to 0 and x is equal to pi divided by 2, that is equal to pi divided by 4. Now second formula we are going to second example. We check. Try to find out this one. It is your home assignment. I equals to 0 to pi divided by 2 under root of sin x divided by under root of cos x plus under root of sin x. Same this as before. This one you have to solve. We take another example, that is if we have I equals to 0 to pi divided by 2 log of tan of x dx. We have to prove it is equal to 0, and we have to find out it, and we consider where it is. Same method, you have to find out this by the help of our these properties. So you will write solution. We know this is integral of 0 to a f of x dx, and we know that it will come out as this by the property of this 0 to a f of x dx, that is equal to 0 to a f of a minus x dx. So we will apply this formula here. Our I will be equal to 0 to pi divided by 2. 0 to pi divided by 2. Now here is log of, sorry, here is a light problem now, but we have to manage log of tan x, that is tan, what is x, pi divided by, what is a, that is pi divided by 2. Here a minus x, so here will come as pi divided by 2 minus x dx. So this implies I equals to now, this is very important, 0 to pi divided by 2 log of, what is tan of 90 minus theta, that is cot of theta. So you will write instead of this as cot theta, that is cot x. This is our integral here. Because of the property, you will write here because this property, and this is our integral now. After that you will so we can apply R equals to now 0 to pi divided by 2 log of, and we can write this cot x as 1 divided by tan x, because this is the inverse of tan x, so it is our integral after here. Now we can write this as I equals to now, we are getting up to here, our I, we are getting I equals to 0 to pi divided by 2 log of tan of 1 divided by tan of x dx. So it will be now equal to 0 to pi divided by 2. Here we know that log of m divided by n, that is log of m minus log of n. Log of m, that is log of 1, minus log of n, that is log of tan x, and then dx. 0 to pi divided by 2. What is the value of log 1? That is 0. So it will be now 0 minus log of tan x, that is minus log of tan x dx, and it will be now further equal to minus 1. We will make it here. It will be minus 1, 0 to pi divided by 2 log of tan x dx. Now we know that we can make here the this, we can use the property as we will change this integral, this interval 0 to pi divided by 2 as pi divided by 2 to 0, and the minus sign will get changed to plus sign. But we have here this I and this I, we will add these two, we will get 2i equals to 0 to pi divided by 2, and then here log of tan x plus this integral, that is minus log of tan x. This is, and then dx, log of tan x minus log of tan, that is 0. So it will be now 0, 0 to pi divided by 2, 0 dx. What is that equal to, beta? What is the differentiation of the 0? That is 0, and here it is 2i equals to 0. 2 is multiplied with I, so 2 will get divided with b. But 2 is, here we can say that 2 into I is 0, but 2 is not equal to 0, that therefore this I must be 0. What is I? I is this integral, that is equal to 0, hence 2d हमने solve करना था. This was my second. Now we take another example. I am making it fast only because it is easy. We have already done a lot of examples. So here we will get 1 plus tan y. So we will substitute by the substitution method. We will solve for it. So we will put here y equals to tan x. So we will apply here the substitution method. Y is equal to tan of x. So here these limits are from 0 to 1, and these are the values of x. Y is equal to 0 and y is equal to 1. So when I will substitute this y as tan x, I will find the values of x at 0 when y is equal to 0, and value of x when y is equal to 1. So here when this y equals to 1, what I get? Here I will get tan of x is equal to 1. So it will be further equal to tan of x is equal to 1. That will be tan of pi divided by 4. So x, here I will get pi divided by 4. And when this y is equal to 0, this tan of x I will get equal to 0, and here x I will get equal to 0. So I am getting now this, also this dy I will get when differentiate of the tan x, that is sec square x dx. I will substitute these values in my integral, that is r is equal to, now I have substituted this y in terms of tan x, so I will substitute these values, this x, y is equal to 0 and y is equal to 1. I will change these also in terms of x. So here when I have y as 1, I am getting at that time x as pi divided by 4. So this one will be pi divided by 4, and y, when y is 0, x is also 0. And then I have log of 1 plus y. So what is 1? What is y here? Y is tan of x, y is tan of x, and then divided by 1 plus y square, 1 plus y square, that is tan square x, and we have after that dy that is equal to sec square x dx. This is I equals to further 0 to 1, 0 to pi divided by 4 log of 1 plus tan x. This will be now equal to 1 plus tan square x, that is sec square x, plus into I have sec square x. This sec square x and this sec square will get cancelled out. I am getting here I equals to 0 to pi divided by 4 and then log of 1 plus tan x. I will write it now here. I am getting I equals to interval of, here we have colony of light, but you have to manage it, 0 to pi divided by 4 log of 1 plus tan x dx. I am getting these things, so it is equal to 0 to pi divided by 4 log of 1 plus, we know by the property number this 0 to a f of x, fourth property dx, it is equal to 0 to a f of a minus x dx. So here a we have pi divided by 4, so it will be here tan of pi divided by 4 minus x and then dx. So it will be now equals to 0 to pi divided by 4 log of 1 plus tan pi divided by 4. This is now 1 plus, this is now formula tan of x minus y. What is that? Tan x, that is tan pi divided by 4 minus tan y, that is tan of x divided by tan 1 plus tan x tan y, that is tan x tan pi divided by 4 and tan y, that is tan of x, and then we have dx. It will be now equal to integral of 0 to pi divided by 4 log of 1 plus tan pi divided by 4, that is tan 45, that is equal to 1 minus tan x divided by, here it is 1 plus tan pi divided by 4, that is 1 into tan x, that is tan x. So here I am getting these things. Now I will do the cross multiplication here. It will be equal to further 0 to pi divided by 4 log of this one, 1 plus tan x will get multiplied by this one. I will get here 1 plus tan x. Here it has 1 divided and it will get multiplied, so plus I got 1 minus tan x. Then we have divided by 1 plus tan x. I am getting this integral equal to now, I am getting equal to 0 to pi divided by 4 log of this tan x will get cancelled out with this tan x, because this is plus tan x, this is minus tan x, and 1 plus 1 will become 2 divided by, here we have denominator 1 plus tan x. It will be now equal to 0 to pi divided by 4. Here log of m divided by n, that is log of m, that is 2 minus log of n, that is log of 1 plus tan x. It is now here 0 to pi divided by 4 log of 2 dx is here, log of 2 dx, and then minus 0 to pi divided by 4 log of 1 plus tan x. You check this one, we have proven it is equal to, it is equal to 1 divided, it is equal to I, this I, because when we substituted the value of y as tan x, we got this I is equal to this thing. So I will write here the integration of this, that will be log 2 is constant to log 2, and the integral of this dx is x from this 0 to pi divided by 4 minus this is now I, so it will be I here. So I will now transpose this I to this LHS towards this, so it will be I plus I, and it will be equal to log of 2. When I substitute this, what I will get, x pi divided by 4, that is pi divided by 4 minus 0 here. So it is now I plus I, that is 2I, is equal to log of 2 pi divided by 4 will come here. So it is now 2 is multiplied, it will get divide here, so it will become pi divided by 2 for the 8 log of 2. This is our answer of this example. So now we have another example. We will solve another example, and after that we will make this unit end. So example is, take this, and this is a very important example. Perhaps if it will be in your book, I will check. Yes, you write here this iota, and this I is equal to 0 to pi divided by 2 log of sin x equals sin x dx equals to 0 to pi divided by 2 log of cos x dx equals to minus pi divided by 2 log of 2. This I have to solve. First I will make the light for. We have to prove this I equals to log this, if we have an integral 0 to pi divided by 2 log of sin x, we have to prove that this is equal to minus pi divided by 2 log of 2, and if we have an integral 0 to pi divided by 2, we have again to prove it, this is equal to this. So we will first prove this one. This one I am going to support you people, because you have to do it. Now first one is I equals to 0 to pi divided by 2 log of sin x. This one I am going to prove, and same procedure you have to follow for this. I equals to, we know that by the fourth property that this pi divided by 2, this is a, here we can substitute x as a minus x, so it will come out as 0 to pi divided by 2 log of sin pi divided by 2 minus x dx, because you know the property 0 to a f of x dx is equal to 0 to a f of a minus x dx. This is your property. So you can write now I equals to, here it is 0 to pi divided by 2 log of, what is sin pi divided by 2? Sin 90 minus x, that is cos of x dx. Now if this is your first equation, this is your second equation, you add these two equations. So I will get, when I will add first and second, I will get I plus I, that is, so you write here adding, add first and second, you will get here I plus I, that is 2I equals to 0 to pi divided by 2, and then log of sin x plus this one log of cos x dx. You will get this. So after that you write 2I equals to 0 to pi divided by 2. This is log of m plus log of n, that is log of m n. So it will be now log of m n, that is sin x cos x. Here you write, because log of m n is equal to log of m plus log of, this is our property here. So you now we will erase it here. It will be 2i equals to 0 to pi divided by 2 log of sin x cos of x. Can I write this like 0 to pi divided by 2 log of this twice sin x cos x divided by 2. 2 and 2 will get cancelled, but I will have benefit here. I will get a formula twice sin x cos x, that is sin 2 x. So it will be now equals to 2i equals to 0 to pi divided by 2. This one log of twice sin x, that will be log of sin 2x divided by 2, and then dx. I am forgetting the dx. So now you will get here 2 iota is equal to I is equal to 0 to pi divided by 2 log of m divided by n, that is log of m sin 2x minus log of n, that is log of 2 dx. So I am getting here 2i equals to 0 to pi divided by 2. This is log of sin 2 minus integral of 0 to pi divided by 2. This log of 2 dx. These things I am getting. Now this definite integral I can easily solve because this is log 2 is constant. I will make it factor out, and the integral of this dx will be x. But this one is a little complicated. We have to solve this. So I will take it as 2i equals to, I will take this I1, this one, because after solving this one I will solve this. So I1 minus, this will be log 2 and log 2, but the integral of this x is x, and we have this interval from 0 to pi divided by 2. So it will be now equals to 2i equals to I1 minus this x. X I am getting x, I have to put substitute the value of x as pi divided by 2, so I will get log of 2 into pi divided by 2 minus this 0. So here I am getting 2i equals to I1 minus log of pi divided by 2, this pi divided by 2 log of 2. So here I got 2i equals to I1 minus pi divided by 2 log of 2. This is my, so I will write it name first, third. Now we have I1 is equal to this I1 sin of 2x. No, but it is log of sin of 2x. I have taken it here. I1 log of sin 2x dx. So I1. So I will substitute here 2x as t. Put 2x is equal to t. What I will get? I will get 2 dx is equal to dt. But the interval is from 0 to pi divided by 2. So here if we have when we have this x as 0, t I will get at that time 0, but when we have x as pi divided by 2, t I will get equal to pi. Okay. So this I1 will become, this I1 equals to now 0 to, I'm changing it into variable t, so it will be 0 to pi. This is log of sine 2x, that is sine 2x square t dt. So it will be now I1 equals to, here you check, it is pi divided by 0. Can I write this as 0 to pi log of sine x dx? By the first property that says we can change this variable into x and d. So here it is log of sine x dx. I am getting I1. This is very lengthy, but it is important. I am getting I1 equals to 0 to pi log of sine x dx. Further, this I1 equals to 0 to pi. Can I write this 0? Here you write it like this: I1 equals to 0. Can I write it 2 pi divided by 2? 2 and 2 will get cancelled, I will get my pi. So it is here log of sine of x dx. We know this property, the 0 to 2a f of x dx is equal to twice 0 to a by the fifth property f of x dx, when this f of x is equal to f of a minus x. Here this is clearly f of a minus, when you will check f of a minus x, you will get it back to this f of x. So here it is now up to you, you have to make this f of x, here you have to find out this f of x is equal to minus f of a minus x. That is, now this will is equal to twice, so here it will be twice 0 to pi divided by 2, 0 to pi divided by 2 log of sin x. क्या है? House. This is now I1 equals to now twice this 0 to pi divided by 2 log of sin x. What is that? Twice. So here I am getting we have done a problem when we have substituted this dx, this x is equal to t, this 2x is equal to dt. At that time this dx will be just dt divided by 2. We have forgotten that dt divided by 2 we had there, so here it will now come out as divided by 2. Sorry, we have forgotten it. So I1 will be 1 divided by 2. It's the problem, most problem. So 1 divided by 2. So when this 2 will come out, it will be 2 divided by 2, and I will get here 0 to pi divided by 2, that is 2, that I will get now. I1 is equal to this log of sine, it is I. So I1 I am getting equal to I. So I will substitute this here. This I1 to I equals to, I am getting this I minus pi divided by 2 log of 2. It is now 2i, this will come out this, it will be 2i, it will get transferred to this side, it will I is equal to minus pi divided by log of 2. Here it will be 2i minus I, that is I equals to minus pi divided by 2 log of 2. This is the answer. Similarly, you can follow the same procedure to this, but this one is very easier than this one. So you will do it, and it is enough. We have to make it complete here. Tomorrow, inshallah, we are going to find out the application of definite integral. That is another unit, application of integrals. So we will exclude here. Have a good time.